Welcome back to Mr. Ace Math. This lesson is on reflections over the x-axis and y-axis. Some stuff you should know before you begin the lesson are the xy coordinate plane, how to plot points, what integers are, and how to multiply by integers. So make sure you know those and let's get started. First of all, what exactly is a reflection? Well, a reflection is basically a transformation that flips a figure over a line. If you think about a reflection in real life, you could think about what you see in the mirror. The image you see in the mirror is your reflection. And the line of reflection is basically like a mirror. It acts as a mirror to reflect an image. So for example, let's say that's our line of reflection, that's our mirror, and we have this triangle here. If we flip it directly over the line of reflection, our new thing, our new image, is going to be our reflection. Think about it. Whenever you look in a mirror and you raise your right hand, it's actually the left hand of your image. So it's kind of like having opposites. If this is the line of reflection and we have this shape, we're going to reflect this image over our mirror, over our line of reflection, and it's going to look exactly the same but just reflected. So the top is further away from the line, the top is further away from the line over here. It's just a mirror image. And how about this? If this is our line of reflection and we have this shape here, a lightning bolt, it's going to look like this because they're mirror images of each other. Think about it, they're also the same exact distance away from the line of reflection. It's not like this one starts this far away and then the image starts right here. It doesn't. They're exactly the same. If this is that distance away, then that's the same distance away. Their height is exactly the same. Everything is basically the same except it's a mirror image of it. So how to name a reflection? After you move a point using the rule, the new point is labeled as a prime. So for example, A becomes A prime. That's how you read this notation. B becomes B prime. And C becomes C prime. This little notation right here, this little 1, is called a prime. So how do we reflect through the x-axis? When we reflect through the x-axis, the y value changes. Here's what I mean. The notation, our point P at the point xy is going to become P prime at x negative y. So the y value changes to its opposite. And the reason why that is because the x-axis acts as a mirror. And what's changing is the location of our y. Because our line goes across, we're going to change the way it looks up and down. So let's take an example. If we have the point P at 10, 7, that's going to become P prime at 10, negative 7 because our y is changing to its opposite. How about P at 5, negative 2? What's that going to be? Well, that's going to be P prime at 5, positive 2. Again, we're reflecting over the x-axis, our y value is going to change. And how about here? P at negative 1, 4. What's that going to become? Well, that's going to become P prime at negative 1, negative 4. Again, because we're reflecting through the x-axis, all of our y values are changing. Our 7 here changes to negative 7, our negative 2 changes to positive 2, and our positive 4 changes to negative 4. How about the point P at 3, 4? What's that going to become? Well, that's going to become P at 3, negative 4. Again, our y changes. How about P at negative 9, negative 11? What's that going to become? Well, that's going to become P prime at negative 9, positive 11. And how about this one? P at 20, negative 30. That's going to become 20, 30. Again, just because we're reflecting through the x-axis, our y value is changing to its opposite. So remember what we said. Whenever we reflect through the x-axis, our y changes. So P at xy becomes P prime at x negative y. So here we have our triangle ABC. And we're going to reflect it through the x-axis. So the x-axis is our line of reflection. It's basically our mirror. So let's change our points to their primes. A at 2, 2 is going to become A prime at 2, negative 2. B is going to become B prime at 0, negative 4. and C is going to become C prime at -2, -3. Again, the y's change to their opposites. And let's see what happens when we do that. We're going to actually reflect through the line of reflection. So let's take a look at what happens to A. A is going to move 2 places from the line of reflection and then 2 places further down, and that's our A prime. B is 4 spaces away, so it's going to move from the line of reflection 4 more spaces away, and that's going to be B prime. And the same thing's going to happen to C. It's 3 spaces away from the line of reflection, so we're going to move 3 more places over, and that's going to be our C prime, and then that's our triangle A prime, B prime, C prime. So as you can see, when we change our points the way we said, when we just change the y coordinate, if we move through the x-axis, we're basically just reflecting through that line of reflection. We're going the same number of spaces across, and that's creating a mirror image, which is here A prime, B prime, C prime. How about this one? Again, our x-axis is going to be our line of reflection, basically our mirror, and we're going to reflect each point through that mirror. And how do we do that? Since we're reflecting through the x-axis, our y-coordinate changes. So A is going to become A prime at -10, +2. B is going to become B prime at -7, +6. C is going to become C prime at 1, +2. And D is going to become D prime at -2, -2. So let's plot those points and see what happens. So that's going to be our new shape, quadrilateral A prime, B prime, C prime, D prime. And if you think about it, it looks kind of like what we did in the last problem. It just goes over the line of reflection. This is C, it's 2 spaces away. C prime is 2 spaces away this way. This was D, we moved 2 spaces, we moved 2 more spaces. B was 6 spaces away from the line of reflection, and B prime is 6 spaces away from the line of reflection on the other side. And the same goes for A. A is 2 spaces away from the line of reflection. A prime is 2 spaces away from the line of reflection on the other side. So basically, we have 2 mirror images of each other, and that's exactly what we wanted because we're talking about reflections. How about through the y-axis? Well, if we reflected through the x-axis and the y value changed, what do you think is going to happen if we reflect through the y-axis? Well, the x value changes. So for example, if we have the point P at xy, that's going to become P prime at -xy. So we're doing the same thing basically, except instead of changing y, we're changing x, because this time we're reflecting over the y-axis. So for example, let's say we have the point P at 10, 7. That's going to become P prime at -10, 7. How about P at 5, -2? That's going to become P prime at -5, -2. How about P at -1, 4? That's going to become P prime at +1, 4. How about P at 3, 4? That's going to become P prime at -3, 4. How about P at -9, -11? That's going to become P prime at +9, -11. And how about P at 20, -30? That's going to become P prime at -20, -30. So how about this example? Last time we reflected through the x-axis, and that was our line of reflection. This time we're reflecting through the y-axis. Therefore, this is our line of reflection. That's going to act as our mirror. So how would each of our points change? We have this triangle x, y, z, and our coordinates are over here. X is at 2, 7. What's that going to become? Well, remember, we're reflecting through the y-axis, so our x value is going to change. Our x-coordinate will change. So that's going to become x prime at -2, 7. Y is going to become y prime at -10, 7. And z is going to become z prime at -10, +3. And when we plot those points, we have a mirror image of our original shape. And that's triangle x prime and y prime, z prime. Again, remember what we said before when we reflected. Our line of reflection. Our x is 2 spaces away. Our x prime is 2 spaces away. Our y is 10 spaces away. Our y prime is 10 spaces away. And the same can be said for our z-coordinates as well. How about for this quadrilateral? Quadrilateral QRST. Remember, we're reflecting through the y-axis, which means our x-coordinate is going to change to its opposite. So, let's change each of our points first, then plot them and see what our reflection looks like. Q is going to become Q prime at 8, 6. R is going to become R prime at negative 1, 6. S is going to become S prime at 0, 0. And T is going to become T prime at positive 8, 4. So let's plot our points. Q prime, R prime, S prime, and T prime. So there is our quadrilateral, our reflection, Q prime, R prime, S prime, T prime. As you can see, if we start with our point Q, Q is 8 spaces away from our line of reflection. Q prime is 8 spaces away from our line of reflection on the other side. R is 1 space away from the line of reflection. R prime is 1 space away on the other side. And the same can be said about our point T and T prime. S is the only point that didn't change its location. So S prime is also at 0, 0. So here's your pause and practice. Just pause and practice. When you're done, unpause the video. After a 3, 2, 1 countdown, your answers will be displayed. Go. So let's go over our answers. Number 1, W becomes W prime at 4, 7. Number 2, T becomes T prime at 5, 15. 3, R becomes R prime at 9, negative 12. And 4, Z becomes Z prime at 5, negative 7. And 5 we can see on the next page. So here we have our triangle STU, and we want to reflect it through the y-axis. And because we're reflecting it through our y-axis, our x-coordinate is going to change to its opposite. So let's change each of our points. S is going to become S prime at negative 8, 8. T is going to become T prime at positive 4, 6. And U is going to become U prime at 0, negative 4. So let's plot our points. That's S prime, T prime, U prime. And so your image should look something like this. Triangle S prime, T prime, U prime. So let's review this lesson. A transformation that flips a figure over a line is called a reflection. When you reflect a shape, it must be reflected through the line of reflection. When you transform a point, the new point is called a prime. Remember, anytime that we transformed a point, anytime we reflected a point, its new point's location was called prime. For example, if we started with A, it became A prime. If we started with B, the new point was called B prime, and so on and so forth. When the figure is reflected through the x-axis, the blank is changed to its opposite, the y-coordinate. When the figure is reflected through the y-axis, the blank is changed to its opposite, the x-coordinate.
Don't forget to like, share, and subscribe.
And thanks for using Mr. Ace Math. Don't just pass math, ace it.